Welcome to Study Loop.
So for part A, let's go ahead and find the partial fraction decomposition. So for this problem, in the textbook, we see that next to the problem there's a CAS symbol. So this means computer algebra system. So that's what we'll be using here. So in the computer algebra system, Wolfram alpha, I've inserted the fraction that we have. Now if I scroll down, I see the partial fraction decomposition. So this is what we'll use for our part A, so I'll go ahead and write this down. So f of x. So partial fraction given by Wolfram. And then the next term. Then I have 816 all over 3993 2x squared plus 1. And then two more terms. And then finally, the last term. So that's the partial fraction decomposition given by Wolfram. Now let's go ahead and use Wolfram in a calculator to find part A and its integral. Let's graph those on the same screen. So let me go to the next page here. So for part B, they want the integral of f. So using our computer algebra system, if I just scroll down here at my Wolfram page, we see that there's an indefinite integral that's given to us. So here's our original fraction, f of x. Here they give us the antiderivative. So let's just go ahead and write that in for our B. So I'll need a lot of more room here. So let me start down here. I'll write it just how Wolfram does. And then we have natural log. You don't have to have absolute value here because 2x squared plus 1 is positive. And then we're still inside of this large parentheses here. Then the next term. Then I have natural log. Let me take a step back, getting a little sloppy here. 8,4 natural log 2 minus 5x in the absolute value. And then the last term here. And then add our constant of integration c, and we'll close off the parentheses. So this was all multiplied by the fraction outside. So that's our antiderivative. And then for part C, we're still on part B too. We'll need to graph the original function, then part A, and then the integral in part B. So here's part A up top, the original function that we had. And then on the bottom, I've just inserted in blue the antiderivative. And so if we look at the graph, we can try to convince ourselves that the red graph is the original and that the blue graph is the antiderivative. So here, for example, if this is true, this means that the red graph should be the tangent line of the blue graph. And we can basically see that's true. Whenever the blue graph is increasing, the red graph is positive. Over here, blue graph is increasing, red graph is still positive, and so on. So this is just more evidence that we've graphed the correct functions. And that's our final answer.